Okay, guys, in this last example for 2.2 blue, we're going to be looking at the inverse of y equals x squared minus 1. We're going to confirm it graphically, and then we're going to ask a question, is it invertible? And so here we go, y equals x squared minus 1. So first step, we're going to switch the x and the y around. Okay, so that's actually performing the act of doing the inverse where the domain and the range switch. Then we're going to peel away the parts. So for our first step, we're going to add 1 to both sides. Add 1. We'll have x plus 1 equals y squared. Then to get rid of that y squared, we're going to take the square root of both sides and end up with the square root of x plus 1 is equal to y. So y equals the square root of x plus 1, or we're saying that f inverse is, hold on just a second, okay. The inverse of x, the function of x, is the square root of x plus 1, okay. So we're going to go under our calculator. We're going to keep y equals x. We're going to clear this out and clear this out. Okay. And then we're going to put in the square root. Oh, let's put in the original one, x squared minus 1. So x squared minus 1. And then we'll come down here and we'll say the square root of x plus 1. All right, so we'll go ahead and graph that. And we've got something really interesting that's happening. First of all, I do see some inverse action going on here with the blue line kind of cutting the graph in half, but I only see part of the black graph. And what that tells me is that this is not going to be a function because it's not going to go up against the vertical line test. And here's the reason why. When we take the square root of something, we actually get two values out. We get a positive and a negative x plus 1. So if I come back to my calculator and I go in and actually put in a fourth function, the fourth function being negative square root of x plus 1, enter. If I graph this now, oh, look at that. We've got a purple part of the graph that just showed up, and my blue line splits right across, and I've got inverse stuff happening on either side of this, and so that's good. But in terms of it being invertible, this is, the inverse is actually not a function. So this function is not invertible because the inverse is not a function. All right, so that's kind of what it looks like when something turns out to not be a function, guys. It's not invertible because the inverse is not a function. So guys, if you have any questions, please let me know. Otherwise, we'll talk in class.